Hello. Today I'm going to talk about how mechanical engineering can contribute to the exploration of the Arctic. I'm going to start by talking about some of the difficulties that we face in traveling there. And then I'm going to talk about some of the technologies that have been developed that are actively contributing to our exploration and understanding of the Arctic now. There are a number of difficulties when it comes to traveling in the Arctic, such as the extreme temperatures and the difficult terrain. Contrary to what many may think, the Arctic is not actually a solid landmass, but is instead made up of massive slabs of ice floating on the surface of the Arctic Ocean. These huge slabs of ice can result in a couple of different obstacles due to their tendency to float, being pushed around by currents and strong winds. They have a tendency to move gradually south, which is a phenomenon known as negative drift. Also, as they float, two or more of these ice slabs can crash into each other. The pressure that builds up from these collisions can result in large uplifts and rubble fields, with chunks of ice that can be as large as small houses. These are understandably very difficult to navigate. Finally, those traveling in the Arctic also have to deal with open areas of water known as leads. These leads are becoming more and more common as temperatures in the Arctic increase, and result as the ice melts away, leaving open sections of the Arctic Ocean. If these leads are sufficiently small, they can be easily navigated around, but other times doing so would take a large amount of time, and so they are simply crossed instead. Now for developments that are contributing to our exploration and understanding of the Arctic. One large contributor to the exploration of the Arctic is Russia's North Pole, or NP stations. These stations make use of negative drift to be able to examine a larger area of the Arctic using only a single station. The idea to use the drift ice as a means of exploration belongs to Fridtjof Nansen, who first accomplished this by freezing his ship Fram into the Arctic ice sheet. Modern NP drifting stations resemble small settlements with housing for explorers and special buildings to house the scientific equipment. NP drift stations carry out a program of year-round research in a variety of fields, including oceanology, meteorology, aerology, geophysics, hydrochemistry, and hydrophysics. There are two types of NP stations. The first is stations drifting on what is known as pack ice. Pack ice is relatively thin and short-lived, which of course means that the NP stations on these are shorter term. The second are built on what are known as ice islands. These are glacier fragments that have split off from the shore. The technology used on these stations needs to be well designed to be able to withstand the extreme temperatures of the Arctic, as well as the rigorous use which they will undergo during the multi-year operation of these facilities. Now for a couple of vehicles that are increasing our ability to navigate the difficult terrain of the Arctic. First is the Hägglunds all-terrain vehicles. These vehicles consist of two units, a cab and an adaptable trailer, which can be used to haul passengers, supplies, or scientific equipment. Each of these units has two powered tracks. These vehicles have a low ground pressure, achieved through full-length wide rubber tracks, and a lightweight body. The pair of driven sections of these units are articulated, allowing for each set of tracks to keep in constant contact with the ground, even over broken terrain. The reason for having a low ground pressure is so that these vehicles can traverse loose snow without sinking excessively. Due to their light weight and the design of the body, these vehicles are also able to float and use their tracks to propel themselves in the water. This is especially useful if those traveling come across leads that are not easily circumvented. Last is an experimental craft known as the Winston Wan Bio-Inspired Ice Vehicle, or BIV. It is a biofueled, propeller-powered vehicle that runs on a set of 3 skis. It was designed to be a type of scout vehicle, traveling ahead of heavier science vehicles and using a special ice-penetrating radar to detect hidden crevices that could pose a problem to the larger vehicles. Its lightweight design and excellent suspension enables it to more easily navigate the uneven ground, while the skis allow it to stay on top of the snow. Its ability to find potential hazards is a very useful feature for Arctic expeditions. In conclusion, the development of things like the North Pole stations, the Hägglunds all-terrain vehicles, and the Winston Wan Bio-Inspired Ice Vehicle have contributed to our exploration and understanding of the Arctic, despite the challenges presented by that environment.